Hi, this is your host Abdul Bhartia and welcome to another episode of TFR Let's Talk. And today we have with us Ari Weil, VP of Product Marketing at Akamai. Ari, it's great to have you on the show.
It's great to be here. Thanks, Swapna.
Yeah, and today we are going to talk about AI at the edge. But before we go deeper into the topic, I would love to know a bit about you, Akamai, from the perspective of AI. If I'm not wrong, you recently rejoined Akamai in January. So talk a bit about what brought you back to Akamai. What changes you're seeing in the market where see Akamai is well positioned. Let's go there again.
Absolutely. Happy to. So I recently did rejoin Akamai because a few years ago, the company acquired a privately held firm called Linode in an effort to start expanding the edge network that Akamai has been building over the last 25 years to really account for what customers have been asking the company for, which is for decades, we've relied on you to take our critical content and help us deliver our applications to users. We've leveraged your edge network that is the world's most distributed edge platform to start applying security at the edge, closer to where user requests originate, but also where attackers might begin some of their nefarious activities. And then over the years, there were questions that were raised by various customers in the media and gaming and e-commerce and travel verticals, which were, with that massive footprint, could we start to use you for compute use cases? Because we've been using hyperscaler clouds. There's a challenge with the central scale up dynamic that exists with the hyperscalers when we're increasingly trying to scale out to reach our users. And so I came back to Akamai as they've really been working diligently to build that connected cloud platform in order to do just that. Take the core computing model, extend it to a distributed cloud and a cloud to edge network, and then provide the ability to deliver a continuum of compute to developers so that they can build the next generation of low latency experiences for their users.
If I ask you, is strategically, how does Akamai look at AI?
So AI is an interesting topic. One, because like cloud before it and many other topics before it, it's become completely overblown in the media. But when we look at what do we mean by AI, think about it first and foremost as businesses are looking to develop a strategy for harnessing the power and potential of AI. Part of that is experimenting with building and training large language models. I believe many industry analysts believe that the majority of companies will end up consuming large language models from a commercial vendor as opposed to building and training the models themselves. And that's simply because the differentiation for many businesses will come in the way that they can leverage AI for inferencing use cases. So think about it as anything from the early forays into intelligent chatbots, the way that Microsoft and OpenAI are looking to enable co-pilots with Copilot Studio and some of the investments that they're making there. And increasingly, different verticals looking at how they can provide a more custom, personalized experience to their users, hyper-personalization in commerce, providing better matchmaking and better in-game services from a gaming perspective. For media, it would be custom manifests and the ability to deliver exactly the sort of tailored interactive media experience that a sports user might want to see or somebody might want to experience in a betting context. And so there's a lot of ways that AI is helping to take large amounts of data, process it very quickly, and deliver an outcome that is not something that was hard-coded in the application beforehand. Now that's sort of the obvious, that's how businesses are looking at AI today. If we look at Akamai's security business, we've been seeing many threat actors starting to leverage AI for nefarious purposes, making bots more intelligent, using AI as a way to more intelligently or more effectively spoof real sites, real users, to defraud businesses or ultimately to take advantage of individuals. And so we've had to build AI into our security platform as well so that we can have AI effectively fighting AI in a way that we can use data and intelligence that we've derived from the network to start to detect human versus bot interaction. And then I think there's just the last part, which is how do you power all of these things, whether it's a business looking to extend its business model and do a better job of engaging with customers, whether it's you trying to fight against the rise of nefarious AI activity online. And that is a platform that we've been building with our compute services, which will help you take lightweight compute, whether it's that AI inferencing that we spoke about, or things like computer vision, or the ability to build intelligent chatbots and extend that closer to where users are. Because if you imagine the way that anybody wants to integrate or leverage AI, they want it to be quick. They want it to feel magical. They want it to feel personalized for them. And all of those things are going to require effective data processing in close proximity to where the user or the service is engaging with the AI in the first place.
And since you mentioned AI inferencing, so I would love to also help you, our viewers, understand what is AI inferencing and how is Akamai leveraging it.
If you think about the difference between AI and a large language model and then the inference on top of it, the large language model is your body of knowledge. Think about it as everything that might be stored up in your brain. So if you've got to train, something over time, you're going to take lots of data and lots of inputs, provide a large amount of time for that data to be turned into basically something that can respond to a voice or a text prompt. Now, the prompting is where we actually apply the inference. So now we want to use that data, that knowledge that we've built up to make decisions on something in a very short amount of time. So the inference will occur when there is a question or something interrogates the model, and then you are using that in order to derive an answer in real time based on basically an understanding of the text or the prompt itself going against this large body of knowledge. So think about it as very heavyweight processing to learn, and then very lightweight processing in order to apply that learning to something in real time.
Now, I also want to talk a bit about what analysts are saying, that they, even IDC, they claim that majority of IT spend on AI will shift from experimenting and training LLMs to AI-powered applications. Now, I would also like to hear from you is how would you define AI-powered applications?
An AI-powered application is really something that can make use of effectively a real-time engagement where you wouldn't have to hardwire it ahead of time. So if we think about the way that people want to use copilots, you don't necessarily know everything that somebody might ask a copilot, but you can train it in a certain way that it can be specialized to answer a certain type of question or to follow a certain line of thought. So for example, like people worry all the time about hallucinations and is AI going to be giving me all sorts of random information that's not true. One way that you can combat hallucinations is by training an AI narrowly in a given discipline. So I might have a copilot that only knows how to answer questions for people who are looking to do business development in high tech or IT, where the focus is cybersecurity, and the sort of application of cybersecurity is endpoint protection. That'll give me a very narrow set of criteria that I can follow in order for whatever my copilot would provide you to stay on the rails, so to speak, and not start pulling from a body of knowledge and providing answers that are outside of its scope. Now that can be changed and applied in all manner of different ways. People might apply, copilots or other AI for gaming use cases. They may apply it for personalized shopping. They may do it for the way that you might want to get preference for your travel itineraries or how you would engage with a hotel when you're on site. So there's all sorts of ways that you can think about training these AI-powered applications. And the AI part is really going to be down to whatever that interaction is between a user and an application. So if the user is expecting to use the application to receive customized, let's say, goods that they might be interested in, then you're going to train your large language model based on your inventory, based on your user sentiment and the cohorts of users that you have, so that you understand how people typically engage with your brand, how people typically would buy maybe the first product and then extend to other goods and services over their lifetime with you. And then that would be applied in the context of, let's say, a mobile application where you would be prompted as a user to say, how are you feeling today? Or are you interested in any of our sales that we might be promoting at the moment? And then you can take a user through a journey based on their interactions, the prompts that they provide back to the application, and a fairly, you can call it narrow, but not meticulously defined path that the user would follow in that application. So you have a constrained amount of data that is going to be engaged with in real time, but you haven't defined, what the starting point and the ending point is with all of the stops along the way. That's where the AI and the inference can start to engage with whatever the user prompts it with. And then depending on what's in your large language model, whether that's your inventory, your sales, things that are applicable to a given user based on their profile or their demographic, you would then match that data and those decisions up in real time as the user engages.
What kind of impact AI, powered application will have on infrastructure? Now, we have to look at infrastructure from two different perspectives. One is, of course, the massive data centers, and the second one is at the edge.
We expect, and what we're seeing is that the hyperscalers are going to continue to build out very large data centers because they need the rack space, they need the compute and the power in order to train and manage these centralized bodies of knowledge. Whether people start with data warehouses or data lakes and then extend it out into a full large language model and an implementation of their body of knowledge on a hyperscaler, these types of things require stateful compute, large data centers, very significant either hot cold or hot hot or active passive sort of deployments so that they can be always available for the business's purposes. Now, when you train an AI, you have time. You have the time to get all of the inputs. You have time to basically see how the model is going to be generating answers to basic questions. So you can create the sort of guardrails that you need as a business to make this something that will be fit for purpose for whatever your given use case is. And typically your business will have internal use cases and externally facing use cases that you'll look to commercialize. When it comes to AI powered applications, though, the problem that hyperscalers have been facing with any type of application for the last decade plus has been one of proximity. So if you think about, AWS as an example, you can build things using EC2, which is their compute environment, and S3, which is their object storage environment, and you can start to create, massive message queues and API distribution services and things of that nature to power very complex, very, engaging applications. The problem becomes if my user is trying to engage with a compute platform from a distance that's very geographically removed from where that compute exists, there will be latency. I'm going to make a request that will create traffic to the application. There will be processing in the application, and I will get a response back. All the major clouds have been experimenting with functions and functions as a service as ways to say we'll create event-driven architectures, some of which will run centrally, others of which will run on CDN platforms, so lighter weight, more ephemeral use cases, so that some of these decisions can be made closer to the user and the impact of that distance won't be felt as much. Now, over time, with multi-cloud deployments, hybrid deployments where some data has to be kept on-prem, the introduction to third parties for things like edge caching and CDN, which is a service that Akamai provides, you start to create a fairly complex operating environment. So orchestrating the application can be challenging when some of your services run on one cloud versus another, where you're sending information out to a CDN to be cached closer to the user, and then you've got to think about what are my dynamic versus static requests, and basically what is the life cycle of my application as the user engages with it. When you bring AI into the equation, you start to add an altogether different dynamic of more data, faster decisions, and faster invalidation of prior decisions that you've already been making, because you're working based on what the user is prompting you with versus a preset journey through a mobile application or a front-end web application. And so distributing that infrastructure becomes important because you have to overcome the challenges of the speed of light. You have to think about the weight, so to speak, of the compute that the user needs. So in some cases, VM resources or lightweight computing could be centrally deployed, but on Akamai, there's a continuum where we can deploy that in our edge pops as well so that it is processing closer to the user. The same thing would be true of data that you might store, of other sorts of distributed data use cases where you may need to keep certain things in sync, like leaderboards in a sporting event or inventory for an e-commerce platform. And so all of these sort of use cases are taking a core infrastructure that the cloud has established and requiring it to now be distributed so that you can have lighter weight, more ephemeral use cases available with that same sort of set of compute primitives, but closer to the user. So basically is what we're seeing is if you imagine something that's elastic like a rubber band, we are taking compute and we are stretching where it is deployed closer to the user. And then basically we're making it so that that user has access to the right sort of compute resources, depending on if they're asking, something that has to be answered immediately versus something that can take a bit longer. And we're delivering those requests and responses to the appropriate level of the infrastructure.
When we look at Akamai, you folks put a lot of emphasis on partner network. Can you also talk about what role does Akamai's partner network play in delivering different AI capabilities? Once again, regardless of where it is, centralized versus distributed, decentralized.
There's different levels of partnership that any business will expect their current technology partners to maintain. I mean, in the cloud, for example, in the centralized cloud, there are marketplaces that exist because a business might have their preferred application security vendor, API security vendor. Maybe they have different types of tooling that they rely on that their developers have become conversant in, and they want to make sure that those are compatible with that sort of an environment. Where Akamai is thinking about our partnerships is we do want to be partnered closely with all of the major cloud platforms, because we know that an architecture is going to span multiple clouds, and different businesses have their preferred cloud vendor or vendors. And that's just a way of working now across the internet. We've seen a lot of news about, different juggernauts in compute that are suddenly partnering and deploying one another's services on one another's clouds. And that is really a response to that market condition where businesses are saying, I need the flexibility to use the software or the partner that I prefer for a given area of my tech stack. Now, where we think about extending AI to the edge and satisfying some of our customers' use cases as they evolve them in the direction of real-time AI processing, then we're thinking about partners like Neural Magic, who are helping us to sparsify some of the models that will be applied at the edge so that we can use commodity CPU resources instead of GPU resources as businesses continue to experiment with AI. It's easier to gain access to CPUs. It's less expensive to run models on a CPU infrastructure versus a GPU infrastructure. We've also partnered with GPU hardware manufacturers so that we can get, as an example from Nvidia, custom tailored GPUs for media and inferencing workloads versus heavier weight large language models. We've also partnered with a company called NetInt so we can provide video processing units at the edge so that we can extend that use case to high-speed video processing for some of our media customers as they look at the intersection between media and gaming and AI. Now, beyond that, there's tooling. There's all sorts of developer tools that will want to create models, to train models, to start to test those models with different types of inputs than developers are used to with sort of static testing frameworks. And then we're also looking at integrations with existing services and devices so that we can apply the AI to the use case more easily for our customers by providing them basically with a full suite of partners that will extend what we deliver first party and really accelerate the route to market, because our customers will be able to take advantage of the flavor of software that they're used to or they prefer on an open platform. And that really is the cornerstone of our approach in cloud, is that we want to have an open platform that allows our customers to choose the software or the partner that they prefer so that they can architect the best possible solution, where Akamai's differentiation will come in our ability to deliver and execute any of those decisions closer to where their users are, certainly more distributed and closer to users than a centralized hyperscaler platform could.
Is it possible for you to share either one or some real world applications that are already taking advantage of Akamai for AI workloads?
Absolutely. So we have one of our customers in the automotive space that's been using the Copilot example in order to provide a better auto shopping experience. So in this case, they're taking their full inventory, the car configurator that Akamai has been delivering using edge computing use cases for years, but now they're applying the knowledge of how people buy from them, the sort of inventory that they're maintaining, including new upcoming models that are available from their platform. We're also looking at ways that people can think about different buying options, different insuring options, and then also localized information like, what is the weather like in your area? What has it been like? Do you want to think about a certain type of vehicle over another, given those types of realities? We'll take other inputs from users' historical purchases and also apply those. And basically the result is a personalized, car shopping experience that will provide users with as close to an experience as being in a showroom with somebody who's knowledgeable about autos and inventory, guiding them through a process, but in a way where you're not engaging with somebody who is maybe thinking about their commission or maybe thinking about their preference of a vehicle or their assumptions about you, but instead it's a totally open experience where there's the inventory, there's the user profile information, and there are the prompts that you deliver, and then the AI takes care of basically tailoring the rest of that shopping experience to you. We've got other examples of it where some of our customers are using AI for computer vision. So trying to understand how they can identify specifics inside of a user-generated piece of content that gets uploaded, and then therefore also providing the user with prompts on, we saw this in the image that you uploaded. Would you like to take the next step? There are certain applications in insurance where this is valid when somebody is uploading, for example, an example of damage to a vehicle or damage to a property, where you can use computer vision to pick things out in the image and get additional information for a processor. We're also looking at it in the social media context of how you can provide the best possible recommendations to a user for content, because again, you'll learn from the user's interaction, but you can also learn from things like parental controls or any sort of regional laws or legislation around the way that content should be surfaced to somebody based on their age, based on their demographic, based on the level of subscription that they might have for you. And all of these things are basically extending more static, rigid frameworks that people have developed over time that might reflect human bias, and starting to apply that in an automated fashion where it's truly based on AI and the data that the company maintains and the way that the user chooses to interact in the moment.
Ari, once again, thank you so much for joining today, and of course, talk about AI at Akamai. Thanks for great insights, and I would love to have you folks back on the show. Thank you.
Thank you. Looking forward to it.